Hello folks, welcome back to Merrill Math. I'm Mr. Merrill, and today's lesson we're going to be talking about factoring non-monic trinomials. So non-monic, by non-monic we mean not one. So if you've seen the monic trinomials, you heard me talk about my mono television. So monic trinomials have a leading coefficient of a 1, or you would just see no number in front of it. When we talk about non-monic, we're saying not 1. So as we're looking at these trinomials, now trinomials I didn't actually talk about in the last one, but you probably saw there are 3 terms. So tri means 3. Nomial, when we get into polynomials and stuff, I don't recall if I talked about this in my dividing polynomials, but when you think about words with nom in them, what they're talking about is name. So we're talking about 3 names, so just 3 different terms. So here we have ax squared plus bx plus c. So this would be our general form of these equations. Now again, we could have any combination of positives and negatives to make up this trinomial here. So the last time we talked about monic trinomials, we were talking about c being our product and b being our sum. But since we have this term here, that sort of complicates things. So the method we're going to use takes a little bit of time. And the first step in that process is to multiply your first and last terms. So the coefficient of your first term and your constant term. If we multiply those, we want this to be our product. And again, our b term is going to be our sum. So let's look at an example of one of those. And we will start with this one. So we have 3x squared plus 10x minus 8. So the first thing we're going to do is we're going to multiply 3 and negative 8. So I'm going to write that off to the side here. So we got negative 24, and we multiplied to get that. And here we have a positive 10. And we add to get that. So we're looking for numbers that multiply to get 24 and add to get 10. Now, since this is a negative 24, this number is going to be how far apart our numbers are. So that actually helps us out quite a bit. So we're looking for numbers that are 10 away from each other and are also factors of 24. The only ones I can think of that do that are 12 and 2. So how do we use that information? What we're going to do is we're going to take this 10x and we're going to split it into 2 different terms. So we know that we have a positive 12 because this is positive and a negative 2. So what we're going to do is we're going to take this 10x and split it into 12x minus 2x. And 12x minus 2x does equal 10x. And then the rest of the stuff sort of comes along for the ride. So minus 8. And we have a 3x squared. So some students get concerned about, well, what if I wrote it in a different order? What if I wrote it as negative 2x plus 12x? It doesn't actually matter. So this process will still work out the exact same no matter what you do. Actually, it would have been more convenient to write it as negative 2x plus 12x because in this case, we sort of have to deal with the signs. So what we're going to do here is a process called factoring by grouping. So we have these 2 little groups out of these 4 terms now, and we're going to pull a common factor out of these 2 terms, and then a different common factor out of these 2 terms, and then hopefully that will lead us to the factored form of our original trinomial. So if we're looking at 3x squared and 12x, 3 goes into 12, and 3 goes into 3, and I have an x in common for both of these. So I can pull a 3x out. In a sense, what I'm doing is I'm dividing each term by 3x. So 3 divided by 3 is 1. X squared divided by x is x, so I just have an x here. 12 divided by 3 is 4, and then x divided by x is 1, so that leaves that alone. Now, I mentioned before about the signs. If we had put the negative sign here, that would have made life a little bit simpler, but I guess this is good to demonstrate this as well. So when we're doing our factoring, one thing we have to be careful about is are signs. So you want to keep track of them all the way through, but you also want to be aware of sign changes or just your sign, I don't know, format. So here we have positive, positive, negative, negative. These terms are opposite of the first two terms. So what you're going to get if this is factorable is you're either going to have the same sequence of signs. It could be like negative, positive, or positive, 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 or the opposite. So if I have something like positive, negative, negative, positive, for instance, then that would tell me that I need to pull a negative out of my second two terms. So since these signs are in the opposite configuration, I have two positives here, two negatives there, that means I have to pull whatever factor I have is going to be a negative. Now, sometimes for this term, now in this case we can actually pull a 2 out, but sometimes we run into the situation where you can't pull anything out. So, you know, they're what we call relatively prime. And in those cases you just pull out a 1 because you have to pull something out. So in those cases you just pull out a 1. Okay, so if we divide these terms by 2, say 2x divided by 2, that's just going to be x. Negative 8 divided by negative 2, that's going to be a positive 4. One thing that pulling the negative out did was it changed these two signs. So negative 2x divided by negative 2 is a positive x. Negative 8 divided by negative 2 is positive 4. And what that created is this situation. So we have another case where there are two terms. These are two factors. These are two factors. We have two terms because they're only connected by one addition or subtraction sign. And they have a common factor. X plus 4 is just a number. If I take a number, I add 4 to it, I get a number. And this number is common to both of these terms. So we can pull that factor out. So I can say x plus 4. And what I'm left with is 3x and a minus 2. And that is the factored form of 3x squared plus 10x minus 8. Now, there are a lot of different methods that algebra teachers like to use for teaching factoring non-monic trinomials. So trinomials where you've got to factor these out and there's a number in front here. The typical method that I've seen, again, back when I was in high school and was taught this, what they basically did was like, okay, what are all your factors of 3 and the combinations of signs that you could get? What are all your factors of 8 and all the different combinations of signs? And just sort of mix and match and see what works. And it feels like guess and check, and I never like guess and check approaches. It's algebra, so you know there's always going to be a path to an answer. So this is a nice method of getting from a problem to a solution, and you didn't really have to do a whole lot of guess and check throughout that. There was a little bit here where we're kind of developing those factoring skills. This is the real key to factoring, is finding the numbers that we can split this into. But the rest of it is going to be the same process every time. So this is really the skill, if you're factoring, that you want to develop. Okay, another example. Okay, so gotta move it down here. For this one, we have a 9x squared plus 12x plus 4. Now, one thing you want to always watch out for when you're working through these problems is if you can pull a factor out of each of these terms, like, if this was 9, this was 18, and this was like 36 or something, we just divide everything by 9. That works out really nice. But in this case, this is divisible by 3, that's divisible by 3, but this isn't. If this was like, 42 or something, that would work, but we can't really do that here. So your first step is always going to be to watch out for, just a constant that you can pull out, which I think we might have an example of one of those if I plan that far ahead. Okay, so first step, we're going to multiply our first coefficient and our last term. So this is a positive 9, positive 4. I've got positive 36. And again, we multiplied to get that term. Our middle term is a positive 12. And we want to add to get that. So we're looking for factors of 36 that add up to 12. So if we're thinking of factors of 36, well, there's quite a few of those. Let's see, 1 and 36, 2 and 18, 3 and 12. Now there's a 12 in there, but 12 plus 3 is 15. We're close. 4 and 9, that makes 13, which is also close. 6 and 6. So 6 times 6 is 36. 6 plus 6 is 12. There's a lot of 6's there. So we have 6 and 6. So we're going to split this guy up. So the nice thing is we don't have to worry about order because these are just both positive 6x. So those are both plus 6x. And my plus 4 comes along, and my 9x squared, that guy comes down too. So now we have this 4 term here, and we're going to do a little bit of factoring by grouping. So we have to pull a greatest common factor out of here and out of here. If we look at all the signs, they're all positive, so we don't have to worry about pulling any negatives out. So that's all very well and good. So these first two terms, it looks like they have a 3 in common and an x. So we take 9, we divide it by 3, we get 3. X squared divided by x, that's x. 6x divided by 3, that's going to be 2. And x divided by x is 1, so I'm done with that. Here we have a couple of even numbers, so I can pull a 2 out. So 6 divided by 2 is 3. The x comes along. 4 divided by 2 is 2. And we look and we say, okay, this is great, because I have a 3x plus 2 and a 3x plus 2. So this will come out here. So we have 3x plus 2. And then the stuff that's left over, 3x and a positive 2, that is our next term. Now, if we really wanted to simplify this down, we could write this as 3x plus 2 squared. So either one of these would be acceptable. Okay, so that is that one. All right, third example. So this one, we have 12x squared minus 39 plus 9. Oh, hey, this is divisible by 3, that's divisible by 3, and this is divisible by 3. The big key for noticing if numbers are divisible by 3 is if we add them up, add up the digits. So 1 plus 2 is 3, that's divisible. 3 plus 9, that's 12, and we already said 12 is divisible by 3. And then 9, we know, is 3 times 3. So what we can do to start, to make our lives easier, because we're probably not looking forward to multiplying 12 times 9 and getting 108 and figuring out what factors. It works, but it makes life a little more difficult. If we pull a factor out ahead of time, that makes life a lot simpler. So we're going to divide each of these terms by 3. If you're going to make a mistake, there's a good chance it would be here. So again, if I'm going to make a mistake, there's a good chance it's going to be here. So very carefully, we're going to divide everything here by 3. So 12 divided by 3 is 4. X squared minus 39 divided by 3, it's going to be 13x plus 3. And we made it through unscathed. So we're going to take our first term and our last term, our first coefficient, not the x squared. So it's just the numbers here. So 4 times 3 gives me 12. I'm going to write that off to the side. Now we want to multiply to get this and add to get negative 13. So here, this is kind of an interesting situation. So this term is positive, which means when we multiplied these terms, they had the same sign. And this term is negative, which means that sign was negative. They were both negative. So we're looking for factors of 12 that add up to 13. Sometimes this doesn't seem obvious or possible, but it's actually just 12 and 1. So 12 plus 1 is 13. So negative 1 plus negative 12 is negative 13. So what we're going to do is we're going to split this term into those two pieces. Now, again, it doesn't make any difference what order you put them in, so it really doesn't matter. It'll still work out because algebra is kind of nice that way. Hopefully I don't run out of paper here. But we have a negative 12x and a negative 1x. We'll just write negative x. And we've got a plus 3 that comes along, and a 4x squared that also comes along. Again, we're going to be factoring by grouping. So we have these two groups here, and we're going to pull out a greatest common factor. Now, one thing we don't want to forget is there's a 3 out here, so we don't want to drop that guy. So these two terms have a 4 in common. That 3 I'm going to pull down here. The 4 we can pull out. Here we have an x also in common, and 4x squared divided by 4x is just going to be x. And negative 12 divided by 4 is 3. Whoops, minus 3. Careful. Again, if you're gonna make a mistake, it's probably gonna be on sign, so be careful about that. So negative 12 divided by 4, that's negative 3. And what do we have here? I'm going to make these square brackets just so I don't get lost in all these parentheses. So I've got 4x times this. So 4x times x is going to be 4x squared. 4x times negative 3 is negative 12x. We're good. Now here I had a positive, negative. Here I have a negative, positive. So they're opposite orientations, right? So these are opposite and these are opposite. So that means we have to pull a negative out, whatever it is. And we notice that, well, they don't really have anything in common. So we're going to pull a 1 out, because you can always pull a factor of a 1 out of everything. So if you run into a situation like that, it's just a 1. So here, all we have to do is just swap the signs. So negative x divided by negative 1 is a positive x. 3 divided by negative 1 is negative 3. And it's nice, whoops, can't forget to close that. It's nice because these two factors, these two pieces here, are the same. So what we're left with is a 3 times x minus 3, and then the stuff that's left over here, so 4x and a minus 1. So this is my factored form of this trinomial. So 12x squared minus 39x plus 9 is going to be 3 times x minus 3 times 4x minus 1. Now, what we could do, if you felt like not having this 3 hanging out here, you could multiply it into either one of these two terms. So you could get something like distribute it in. So we don't want to distribute it into both of them because that would be the same thing as multiplying by 9, and that's not the same thing because this is a 3. So what we could do is something like, 3x minus 9 times 4x minus 1, or we could do something like 12x minus 3 times x minus 3. In either case, it's equal to the same thing. Now, in terms, if your algebra teacher is like really picky and they're like, I want it completely factored out, well, then that answer would be this. If you want something that's just really simple to FOIL, you might do something like that. In either case, both of those are technically correct, which, as we know, is the best kind of correct. So that's a few examples of non-monic trinomials. Hopefully that helped if you're having trinomial woes. All right, thanks for watching.